basically going to continue segmentation, and from now on it's just really different examples of different things. As I mentioned already, there's a lot of segmentation is the basic problem that you need to solve before moving on to anything else, quantifying anything based on the images. And therefore there's a lot of attention, of course, that segmentation has has captured. And we're just gonna from now on try out different methods. Chances are, for whatever image that you're working with, you're gonna have to try out a number of things before you're happy with the result. So we had a very basic example last time, which was glass beads. These glass beads, they look really pretty and beautiful on the image. Regardless, once we actually segmented them, we did see some of the little imperfections. These imperfections, for the most part, are actually real because those glass beads have some imperfections. But here and there, it's actually the imaging problem or things slightly moving during the imaging. So for anything X-ray, we know that things have to stand still for the duration of taking one image, and especially if you're rotating the images, for instance, glass beads could slightly move while you're rotating that image. So that can be a problem. Now, we got the three-dimensional figure, and then we did the very basic quantification, like what is the porosity. And the one question that we did not answer now, but we're answering in the next lecture, is connectivity. Now, in this particular image, it was actually visually obvious that the pore space in between glass beads is connected, but that's not necessarily the case, especially as porosity goes below. If you have, give or take, the rule of thumb is this: if you have pore sizes that are on the single length scale, so I don't have a multi-scale situation or multi-scale features, then the moment you drop below 5% or so, you're going to disconnect that porosity. Unless it's a very, like especially if you are in a sedimentary rock, because you're moving on the outside of convex objects such as spheres or grains, and basically that's roughly where the limit is. You can have, of course, if you have one thin fracture, you can thin that fracture down to any porosity you'd like and still be connected, of course. So you can find almost mathematically the examples where that porosity could drop really, really low. But if you have sort of a sedimentary rock with single scale of pores below 5%, that pore space will likely not be connected. Some different scale or some grains of different scale should be at work if it is. So more often than not, we of course want to know what is the connectivity as one of the first questions that we're asking. Now, for the purposes of answering these two questions, whatever segmentation we actually did in class, I declare that it's just fine. Whatever small imperfections, we didn't go and spend any time fixing them. And of course, you can run a histogram on binary image to get the number of voxels in the volume if you need to. Okay, so let's now move on to some different examples. And now we're actually going to try some filtering before we actually segment. So let's download this Benheimer sandstone example. It should be in your segmentation exercise. Let me just get rid of these. This is my previous class, apologies. So open it up in Fiji, and basically what I want you to do is, I think we opened this already, so this part of the exercise might be outdated, but in case you don't remember what this image was, play a little bit with image types until you get something that looks like this. That's when you will know that you imported it correctly. And we will work on this in class, but I will want you to collect the results as you go into a PowerPoint or a Word document or whatever looks good to you. And I want you to have basic visualization in there. So report and save slice 100, also orthogonal views, just for you to quickly review how to do those, and report the histogram of the sample. And then I'd like you to segment this image and calculate porosity. And then try various filters, and again, redo the segmentation just to see what the influence of these filters is on the final result. And you want to actually use the 3D version of these filters in the process filters menu, because the standard ImageJ, Fiji, those work slice by slice. Okay, so they're not going to form three-dimensional neighborhoods for median filtering, for instance. And then last thing, in order to quantify the difference between these different filters or any two images, recall that you can use process image calculator. You can also do that difference for the segmented version as well. Okay? So let that be our first assignment. And I'm going to, meanwhile, so everybody has a copy of slides, right? If you need to.